Alright guys, so now we are going to talk about the lecture 3.3, the unit circle and circular functions. The knowledge of the trigonometric value for cosine and sine will help you to be more efficient. You have to remember this trigonometric circle value for the final. You just need to know how to find the value of cosinus and sinus for the first quadrant. And when you know the first quadrant, all the other quadrants will be very easy to remember. So remember that is a circular function starting with the unit circle, or for the radius, if you're defining and using the Pythagorean theorem, you got x squared plus y squared equal 1. R being equal to 1, the length of the arc will be equal to theta. And basically what do we have is if you have the initial side right here and the terminal side, r equal 1. Let me take the red one, r equal 1. Let me, hopefully I'm able to, there we go. So r equal 1. R equal 1, we're having theta right there. And this is s equal r multiplied by theta, r being equal to 1, s will be equal to theta. Remember that each point is defined if you have the y-axis and the x-axis. Y-axis and the x-axis. The point right here is defined with a value of xy, which is in fact a value of cosinus theta and a value of sinus theta. You are reading the value of sinus on the vertical axis, and you are reading the value of cosinus of your angle theta on the horizontal axis. Okay? So, remember that you need to know perfectly well. It's much easier for you because you will be more efficient. All this trigonometric function. And let's jump to a practice problem right now, okay? To find all the value of your trigonometric circle. So let's start with the angle 30 degree, and we're having 30 degree right here. So we're having 30 degree right here. We have 0 degree, which is 0 pi. 30 degree, which is pi over 6. Then we have 45 degree, which is pi over 4. Then we have 60 degree, which is pi over 6. Then we have 120 degree, which is 2 pi over 3. Then we have 135, which is 3 pi over 4. We already talked about that in a previous section. Then we have 150 degree, which is 5 pi over 6. Right there we have 180 degree, which is pi. And I will let you finish the rest. At least I'm going to write in degree, 210, 225, 240. Then the rest right there, 270, etc. So, let me get rid of that. All right, so maybe I should, what's going, there we go. So, you must remember that for 0, 0, you will have a cosinus equal to 1 and a sinus equal to 0. Then cosinus pi over 6 will be equal to square root of 3 divided by 2 and 1/2. Then the cosinus pi over 4, I'm going to have square root of 2 divided by 2 and square root of 2 divided by 2 for the sinus and the cosinus, both positive, by the way. And then for pi over 6, I got 1/2 and square root of 3 divided by 2. And for the last one, we're having 0, 1, as the sinus will be equal to 1 and the cosinus will be equal to 0. Very quickly, I know that right here it's going to be -1 and 0, my cosinus will be equal to -1, and right here my sinus will be equal to -1 when my cosinus will be equal to 0. I'll let you finish to fill up all of this value. It's pretty easy, pretty simple, because once you know what do you have in your quadrant 1, and your quadrant 1 is defined in this area right here. This is your quadrant 1, this is going to be your quadrant 2, this is going to be your quadrant 3, and this is going to be your quadrant 4. You will be able to define very quickly all the value for cosinus 2 pi over 3, 3 pi over 4, 5 pi over 6, and so forth. So let's state the domain and the range of a circular function. When I look at sinus s, which is equal to y, I know the domain will be -infinity plus infinity, and the range is going to be -1, 1. For the cosinus, which is cosinus equal x, the domain is going to be also -infinity plus infinity. There is always a parenthesis for when you're dealing with -infinity or plus infinity, and the range is going to be also -1, 1. For the tangent now, the domain which is the tangent, which is y divided by x, therefore sinus s over cosinus s. Well, the domain is going to be the set of value of s such that s part of the real number and s different than odd number must be plus pi over 2. The domain of a tangent is pretty much very easy, because the domain of a tangent, well, remember the tangent is a fraction, and therefore it cannot be divided by 0. Cannot divided by 0. Therefore, that implies that the cosinus s has to be different than 0, and so that means that s has to be different than pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. Okay? So now if we want to find the value of sinus of 7 pi divided by 4, which is going to be equal to minus square root of 2 divided by 2, and we look at the trigonometric circle and the sec of 2 pi divided by 3, well, which is 1 over cosinus 2 pi divided by 3. When you look at your trigonometric circle, the cosinus 2 pi over 3 is minus 1/2, so you have 1 over minus 1/2, which implies that the sec will be equal to -2. Find some approximate circular function value. Use your calculator. That is the advice. Use your calculator in radian mode. This is very important, in radiant mode. And if you look, by example, to tangent of 0.925, you will find, and I'm not giving you the answer because it will be part of the question to make this video more interactive. Find a number given a circular function value. I'm going to ask you to find cosinus s equals 0.75. So I'm asking you to find the value of s. Then problem number 6, angle elevation of the sun. So we're having sinus theta equal cosinus d, cosinus L, cosinus omega plus sinus d, sinus L, d being the angle of declination, which is due to the angle of Earth, L the latitude, and omega the rotation of Earth since noon. Find theta for Sitka, Alaska on February 29, 2008, which means a latitude of 57 degrees, angle of declination of negative 0.1425 at 3 p.m. and 10 a.m. So if theta is the angle of elevation, well, when theta equals 0, we are at sunrise. We are at sunrise. And when we are at theta equal pi over 2, we are at high noon. Okay? It's noon. At 3 p.m., the rotation of Earth since noon is equal to 3 hours after 12. So afternoon, after 12:00. Therefore, omega equals 3 over 24 of a rotation of Earth. I'd like to remind you that the Earth rotates in 24 hours. And so if I want to transform that into radiant, one rotation equals 2 pi radiant. One rotation equal 2 pi radiant. That means that omega will be equal to 3 over 24 multiplied by 2 pi. Therefore, equal to 1 over 4 multiplied by pi. So we'd say that omega equal pi over 4. So now sinus of the angle theta is going to be equal to cosinus of negative 0.1425 multiplied by the cosinus of 57.1 degree multiplied by pi divided by 80 multiplied by pi divided by 180 to make the angle in radian multiplied by the cosinus of omega that we now know is equal to pi divided by 4 plus the sinus of negative 0.1425 times the sinus of 57.1 multiplied by pi divided by 180, because I want to make sure that my sinus will be the angle are written in radian. Therefore, the value of the sinus of your angle theta equals 0.2609. I'll let you find the value of theta, and you will be able to tell me the value of theta for 10 a.m. Based on the same idea that I presented you right now. We just did, so you're going to find theta at 3 p.m. At 3 p.m. And it will be up to you to find at 10 a.m. with following the same process. I do not give you the value of theta, as it will be part of a question that you will have to answer when you are watching this video, actually. So work this out, and I think everything will be okay. We will work the problem in class. Take your time, work hard, and I can guarantee you everything will be all right.